So last class we learned what our I stood for. I is our imaginary number. It stands for the square root of -1. So powers of I are repetitive. So what happens with our I is you'll get i's to some really large exponents. What we need to do is we need to simplify them down, and when we do that, they repeat a pattern for it. All powers of I can be expressed as one of 4 values, and it just keeps repeating through this pattern of those 4 values over and over and over again. So recalling from last class, I is the square root of -1. And then if we take the square root of -1, which is the same as saying you're taking your I and you're squaring it, that's going to equal a -1. Because remember, that square root sign and that square cancel each other out. It's just going to be -1. So now we're going to find I to the third and I to the fourth. So I to the third means that it's I times I times I. You're multiplying it 3 times. So that means we have radical 1, or -1 times radical -1 times the square root of -1. You're multiplying that 3 times. We already know if I multiply it 2 times, it becomes a what? -1. We already figured out. If we multiply it 2 times, we get a -1. So I can take this, so that really is a -1. And then I can't do anything to the square root of -1. That's just going to stay the square root of -1. Which means that's -1 times I. If I replace the square root of -1 with I again, I got -1 times I, which is really just -I. So I to the third power is -I. So then I to the fourth power means it's the square root of -1 times the square root of -1 times the square root of -1 times the square root of -1. We multiply it 4 times. But again, as we said, if we multiply just 2 of them, that turns into -1. So then these other 2 over here would turn into -1. And we're multiplying. So what's -1 times -1? Positive 1. Negative times negative makes that a positive 1. So I to the fourth power is a 1. So our pattern that we have, we'll write it over here. I to the first is just simply I. I squared is -1. I to the third is -I. And I to the fourth is +1. And it just keeps going through that pattern over and over and over again. So then therefore I to the fifth takes the place after 4, so it goes back up to the beginning. So I to the fifth is the same as I to the first, so it would just be an I. And then I to the sixth is the same as I squared, so that's going to be a -1. I to the seventh is the same as I to the third, so that would just be -I. And then I to the eighth is the same as I to the fourth, which would just be a 1. So as I said, just keeps going all straight through this pattern. So again, let's look at the table. I to the first is I squared is -1, I to the third is -I, and then I to the fourth is +1. And then it repeats that pattern. I, -1, -I, +1. So the fifth is I, to the sixth is -1, to the seventh is -I, to the eighth is 1, and then it repeats it again. I, -1, -I, +1. So then if we were to keep that pattern going, we ended up with I to the 12th, so I to the 13th is the same as I to the 14th is -1, I to the 15th is -I, and I to the 16th is 1. So then just going to keep repeating. It keeps going again. I to the 17th would follow the same pattern, 18th, 19th, 20th, and so on and so forth. So what we do is, in order to figure out which one it's going to simplify to, whether it's I, -1, -I, or just 1, what we do is we take the exponent and we divide it by 4, because it repeats that pattern of 4. There's always 4 numbers it's going to be. Divide it by 4, that's going to help us figure it out. Now when we use our calculator to divide, we're going to get decimals that help us figure it out. So if you divide something, like for example, let's say we had I to the 21st. We're trying to figure out what that's going to simplify to. So instead of trying to sit there and go through the pattern, just keep writing it out over and over and over again, because that gets to be a bit much. We divide the exponent of 21 by 4. So let's do that in our calculators if you need to. What do we get? What's our decimal? 5.25, right? 5.25. This decimal 0.25 means it's going to be I to the first. If you divide and you get a decimal of 0.25, that means it's going to be the same as I to the first. If you divide and you get a decimal that's 0.5, that means it's going to be I squared. If we divide and we get a decimal that's 0.75, that means it's going to be I to the third. And then if you divide and you don't get a decimal, you just get a whole number, that means it's I to the fourth. Sometimes calculators might show you 0.0. That doesn't happen often, but depends on your settings. It'll show you 0.0. It's going to be our pattern. So this one, I to the 21st, divided by 4, I got that decimal 0.25. That means that's going to simplify down and just be I. Let's try some examples on the back. So we're going to be simplifying these and expressing them in terms of I. Again, I to the first, -1, -I, or I to the first. When you simplify, you should have nothing higher than I to the first. So for this one, 25, divide that by 4. Let's see what we get. 25 divided by 4. You're going to get a decimal. What is it? 6.25. So that decimal 0.25 means that this is the same as I to the first, which is just simply I. Let's try the second one. I to the 16th. So let's take that exponent of 16 divided by 4. What do we get? 4. We get a whole number. So that means this is the same as I to the fourth, which is a 1. And then let's do the same thing for 28. 28 divided by 4. 7. We get another whole number. So that means that's the same as I to the fourth, which would be another 1. So we got 1 minus 1 there. So our answer would be 0. So number 3, got to follow our exponents rules. We have an exponent raised to another exponent. So this is what we call our power to a power. What do we do with those two exponents? Not add. Those ones we multiply. Exponent raised to another exponent, you multiply two of them. That becomes I to the 18th. So now let's divide. What's 18 divided by 4? 4.5. So 0.5 means this is the same as I squared. So that's going to equal a -1. So looking at number 4, 5 times 6 gives us 30. This is the one where we would add our exponents because you're multiplying. So 5 plus 11 gives us I to the 16th. So perform the operation first. And now let's simplify our I. So 16 divided by 4 gives us 4. It's a whole number. So that means this is the same as I to the fourth, which what is I to the fourth? 1. So this is really 30 times 1, so it's just going to be 30. And then number 5, we got exponent to an exponent. So we'll multiply these first. So we get I to the 10th times I to the 7th. So now you're multiplying with a like base of I, so we add those exponents, so that becomes I to the 17th. Exponent times to another exponent, multiplying those bases, you add them. So 17 divided by 4, what do we get? We get a decimal. What's our decimal? 4.25. So 0.25 means it's the same as I to the first, which is just simply going to be I. So again, you always got to simplify those i's. It's one of those 4 things. I, -1, -I, or +1. So again, when performing operations with square roots that have negative radicands, remember those radicands are those numbers under the radical sign, you want to first rewrite each negative radicand in terms of I, and then simplify as possible. This is kind of just reviewing more of what we were doing last time. So we got 2 radicals that we're multiplying here, but there's negative numbers underneath, so we've got to first rewrite this. -16 would become 4I. If you still need to do the work for it, you can, but square root of 16 is 4. Because it's negative, it becomes I. Square root of -9 would become 3I. So now that we've changed those into i's, we can actually multiply. So 4 times 3 gives us 12. I times I gives us I squared. And then what does I squared equal? -1. So this is really 12 times -1, which would be -12. You should never have an exponent higher than 1 on your i's. So for 7, all you can do is take the negatives out of those radicals. Those aren't perfect squares. 7 and 2, and there's not a perfect square that goes into 7 and 2, so those are going to stay as radical 7, radical 2. So then we multiply our i's. I times I gives us I squared. Multiply those numbers underneath the radical. 7 times 2 makes that radical 14. So again, I squared simplifies to be -1. So we get -1 radical 14, or you could write it as just negative radical 14. Either of those would work. So number 8, we got this negative here with the 3, so we got to pull that out, makes it an I. And then it's times 4 radical 5 still. So all I've done is I've taken out my negative. So still the same rules, multiply those numbers out in front. So that makes that a -8I. Multiply the numbers underneath. 3 times 5 gives me a 15. Now I have I to the first, so I don't need to simplify that. That's already as simplified as it's going to get. And then we have a 15 under the radical, so there's no perfect square that goes into that. So that is our final answer there. So number 9, again looking, we have a negative right there with our -30. We got to clean that one up first. Is there a perfect square that goes into 30? Nope. Because you got 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. None of those are perfect squares. So what we do have to do first is bring that negative out in the form of an I. So I still have my square root of 3, I still have my 2 radical 6, but now it's going to become plus I radical 30. Got to take that negative out first. So we distribute our radical 3. Numbers under radicals can be multiplied together. Numbers outside of radicals multiplied together. So that's why that becomes 2 radical 18. 3 and 6 are both underneath. They get multiplied. And then it's plus I radical 90. 3 times 30 gives us 90. So now we got to do some simplifying. What's our perfect square that goes into 18? 9 and 2. Square root of 9 is 3, but then times that 2 makes that a 6 radical 2. What's our perfect square that goes into 90? 9. 9 times 10. Then we get 3i radical 10. And then the numbers underneath the radicals are not the same, so we can't combine those. It's just going to stay that way. 6 radical 2 plus 3i radical 10. So then for 10, the negative 80, is there a perfect square that goes into 80? There's actually a couple of them. We want to find the largest one. Yep, 16 and 5. So the negative 80 was broken up into that negative 1, the 16, and then the 5. On the bottom, all you can do is break it apart, the negative and the 5. So we got 4i radical 5 on the top because the square root of 16 is 4. Square root of negative 1 is I. On the bottom, we got that I radical 5. So what can we cancel? Radical 5 and the I. So we're just left with 4. So on our last one, the 11. What's our perfect square that goes into 24? Perfect square into 24. 4. There is no perfect square that goes into 3, so we can just take out the negative and make it an I in front of the radical. So the square root of 4 is a 2, but times the 10 that was already there is where my 20i radical 6 comes from. And then that's a negative 2i radical 3 in the bottom. So now we'll divide. I's are going to cancel because they're the same exponents. Remember, anything with the same exponents cancels. 20 divided by negative 2 will give us a negative 10. And then remember, we divide those numbers underneath the radical. So 6 divided by 3 gives us a radical 2. So negative 10 radical 2 ends up being our final answer.